Since the 1950s, customer care professionals have been manning the phones to answer your most pressing issues. But over the last 60 years, consumers have become less keen on the telephone and don't mind saying so. Meet Joe. Joe is a phone agent at Acmecorp, and boy, Joe sure is having a hard time with an angry customer. Seems like Joe doesn't know that customers don't like to be kept on hold, that their time is valuable, that providing their account number over and over is a frustrating, lackluster endeavor. Poor Joe. But what Joe doesn't know is that Zoe is keeping her customers happy by having a friendly chat with them wherever they are, at home, at work, and on the go. And not just one customer. Zoe can easily interact with 3 customers at once, lowering the cost of engagement and increasing the number of satisfied customers. Good work, Zoe. Poor Joe. He's really getting an earful from this customer. If only his manager would come to help him out. But there's no way to let his manager know. What will Joe do now? Uh-oh. Looks like Zoe has an upset customer as well. Good thing Chloe, Zoe's manager, knows when a customer needs special assistance based on the types of words used in their conversation. Don't be like Joe or his manager. Keep your employees and your customers happy with LiveEngage for a modern, customer-friendly experience at a fraction of the cost of voice. Remember, give choice, not voice.
Okay, thank you very much for our creative team. Some facts about our CI system. In LivePerson, we have about 160 microservices that were actually, 4 years ago, we had one monolithic big server, and we separated it into many, many microservices. We release about 1,600 releases a year. That is managed by 10K weekly builds. We manage all our code in GitHub. We have 1,400 Git repositories. We use TeamCity, similar to Jenkins solution, to manage our build configurations. We have 70 build agents, 30 development teams here in Israel in Ra'anana, split it in all small and bigger teams. And we have 4 CI members together with 3 members that manage the infrastructure of the CI system. Today we're going to speak about some numbers about OpenStack in production, and how we solve the resource problem in R&D, and how we make faster development with OpenStack, and how we develop the plugin in order to enable it, and how we improve this process with using instances from OpenStack from a predefined pool. Okay. OpenStack in LivePerson is used as the main infrastructure. It's one of the 20 biggest companies that adopt OpenStack. We have 20,000 physical cores, 40,000 virtual cores, 8,000 VMs divided in 7 data centers all over the world. All our 100% of our applications and web tiers are on OpenStack, and today we are upgrading to Kilo version around all our data centers. Most of our code in LivePerson are written in Java, some of them in Node.js. Okay, and these are a set of tools we use in order to build our pipeline. Okay, we use Maven as our main configuration tool for the building system. Okay, we use Puppet to manage our servers and install. We manage our code in the GitHub. We use TeamCity as our build tool, and we run tests using the Selenium and JUnit. I want to show you what is a cycle. I mentioned before we have about 160 microservices. Each microservice goes through this flow. So actually when a developer makes a change, a code change, it goes into the GitHub. The TeamCity identifies the change and execute the maven lifecycle. Okay, he builds and compiles the code, run the unit tests, and then it goes through the packaging stage. We take all our application, we pack them into RPM and push them into YAML repositories. Afterwards, we have the Puppet configuration that we use in order to deploy our servers on our instances. Some of our instances are, most of our instances are dedicated server. Some of them are from VMware and some of them are from OpenStack. And the last stage will be the system test, and afterwards the security analysis. Now each microservice, in order to get to production, he has to go through this entire process. And today, I want to focus in the deployment stage. So because we have so many microservices, and each service, each change of code, we have to run this process. And if we have a lot of changes at the same time, that's causing, if someone is using the server, other one that makes change needs to wait until the entire process is finished. Okay, so we can do only one build at a time. Okay, so that actually leads us to a queue. Okay, so we have the problem we were facing as that we have a queue in the system. Okay, this is our bottleneck. Okay, so actually in R&D we're managing about 600 instances to serve all our microservices, causing a long queue. Most of these instances, because they get reinstalled every time and with different applications, sometimes these servers get dirty, all kind of unnecessary installation packages on it. This causes all kind of build breaks. Okay, and we want to be like production. So, okay, so the goal of this project is we want to enable parallel deployments. And actually what we want to do, we want to create the instances on the fly. Okay, so this is the solution we chose. And because most of our services are written in Java, we use Maven as our main configuration tool. And we use it also in order to extend and integrate in all kinds of other solutions. How many of you are familiar with Maven? Please raise your hand. Okay, I can see not many of you. So, Maven is a build configuration tool for Java project. It has a well-defined life cycle, so you can define any cycle you want. It's easy to manage. You can manage it within your project. It's part of your code. Okay, it has a dependency management, and it makes the build process very easy. Along with it, in order to integrate and to use OpenStack, you have to write your plugin. Okay, so I choose in the OpenStack project, you can find many many clients that you can integrate with the system. You can find examples like if you're running Ruby or you're running any other, you're writing your code in different languages, you can find other APIs to use. I chose the OpenStack SDK for Java, and it enables me to create and provision instances. Okay, so I want to show you how simple it's to do it. Step one, you have to be a little familiar with Maven, and Maven is a collection of plugins. Okay, so I chose to create a plugin that will work against the OpenStack. So the first step will be to create a plugin. So in Maven, you can use kind of a skeleton or archetype to generate the template. So the second step will be to use the dependency of the OpenStack 4J that is supports the version of the OpenStack you're using. Okay, the third step will be to authenticate. Okay, you can pass the authentication. You can write a class that passes the authentication to your OpenStack system. Okay, and the fourth step, you have to create your goals. Okay, so the two major goals is, the first goal is during the CI process, you want to start an instance, install it, use it, and at the end delete it. So compute and delete instances are basically two classes of Java that you develop in order to integrate it into your flow. For example, if you have a service that is built of a web layer Nginx and two Tomcats, okay, so you have to give your users or your project to define it in the Maven configuration. So this example, you can see that we have two apps and one Nginx. So 3 OpenStack instances will be generated during the build process. Okay, so how that was the easiest part of it is to start instances in OpenStack. But how do we connect them all together? So because we're using Puppet, for our installation and to configure the servers, so Puppet has a library. It's called the Factor, and it's available during the Puppet execution. So actually what we do, you can create your own custom facts on each instance. So during the provisioning state, we just create a file. You can use either JSON format or YAML format. And as a result, on each instance, we'll get the specific role ID. Okay, so for instance, role 1 will be app 1, role 2 will get app 2, role 3 will be the Nginx. And in order to connect between the Nginx and his nodes, you have to create the balancer member or the upstreams as the specific host names that you retrieved during the provisioning state. Okay, and if you want to expose it for others, for other stages, like system test, you have to create an alias, a DNS alias, in order to access the service. Okay, so actually, what we were facing, we had to change the static declaration to the dynamic one. Okay. Okay, so if we go to, instead of using the node declaration, okay, we use the dynamic declaration of this example. And the other example, in order to, if we used to specify the exact nodes we used when we used the static instances, so over here, this is the, down over here, there's an example of the dynamic upstream members. Okay, so what is the advantage? Now we can run as many build processes at the same time for each commit. Each instances are provisioned clean from a fleshed state, and we have it production-like. Okay, and no resource waste, and it's very, very easy to scale. If you want to add more nodes or apps into your service, you can add them easily. You don't need to make any further change, and you can run your load tests against it. Another problem, after we released the first version of the provisioning, actually the developers that were starting to use it, they said, but now it adds another 3-4 minutes to the build process. Why do we need it? So what we decided is to create a pool of instances, predefined, that are ready for deployment. Usually when you have an image, to connect it to the site, you need to at least reboot it once. Over here, they get an instance that is already connected to the same site or to the same environment that they were provisioned. And that way we can decrease the time of the instance boot. Okay, so in order to enable, we had to extend our plugin. So we added 2 new goals. One of them is the queue manager that always feeds the pool with new instances as needed. And the other one that knows how to take the instances from the queue. Thank you very much. Any questions? Okay, thank you.